In this video, I will show you how to take the equation of a hyperbola that is not given to you in standard form. We'll rewrite it in standard form, and then we will identify the key values associated with the hyperbola and sketch a graph. In the standard form of a hyperbola equation, we always have equals 1 on the right-hand side. So the first thing we need to do is divide everything by 36 so we can get the 1 that we are looking for in standard form. All right. So when you reduce this down, you're going to get x squared over 4 minus y squared over 9 is equal to 1. So it's easy to tell that the center is going to be 0, 0, because we just have x squared and y squared. So the center is definitely going to be 0, 0. Let's go ahead and write that down. Okay, and graph it. So there's the center right there. Now let's go ahead and find the vertices. The first denominator, the positive term denominator, is always going to be our a squared. So a squared is equal to 4, which tells us that a is equal to 2. Now, since the 4 is the denominator of the x term, I'm going to do my plus or minus 2 in the x direction. So I will go 2 to the right and 2 to the left. These are my vertices. So negative 2, comma 0, and 2, comma 0. Those are the vertices. Now, how about the co-vertices? The second denominator, the negative term denominator, is always going to be b squared. So that means b is 3. Notice that the 9 is the denominator of the y term. So I will do my plus or minus 3 in the y direction. So up 3 and down 3, these are my co-vertices. So 0, negative 3, and 0, positive 3. All right, let's go ahead and draw the rectangle that contains these vertices, because that will allow us to sketch the asymptote. So draw a rectangle as a dotted line that contains the vertices and the co-vertices. The asymptotes of the hyperbola will go through the diagonals of the rectangle. So I will have one asymptote that goes like this. And I will have another asymptote that goes like this. So we could draw the sketch of the hyperbola right now. Remember that these red dots are the vertices. So my branches are here, approaching the asymptotes on either end. So there's my hyperbola. Let's go ahead and find where the foci are. For the foci, we will need the c value. Remember that for hyperbolas, the relationship is c squared is equal to a squared plus b squared. For ellipses, it was minus, but for hyperbolas, it is plus. So that's going to be c squared is equal to 4 plus 9. So c squared is 13. So c is the square root of 13. It would be useful to know the decimal approximation of radical 13. So the square root of 13 is approximately 3.6. So that'll be useful for graphing purposes. So if I go 3.6 to the right, that's going to be about here. Okay, 3.6 to the left is going to be about here. Now when I label these points, I can't use the 3.6. I've got to use the radical 13. So look, the y-coordinate is just going to be 0. See how it's right on the x-axis? So we know the y-coordinate is going to be 0. It's just a matter of what's the x-coordinate. Because the c value was radical 13, it's radical 13 to the right. So this will definitely be a radical 13. And similarly, this one will be negative radical 13, comma 0. Okay, so those are the foci. All right, we might as well get the eccentricity out of the way. Eccentricity is always c over a, so that'll just be radical 13 over 2. Now, how about the asymptotes? Here's a model that you can always use to find the asymptotes. Y minus k is equal to plus or minus m times x minus h. Notice how I'm using h and k. This is really just the point-slope form of a line. But the point that I always use is the center of the hyperbola, because that's the one point that's on both asymptotes. That's why I'm using h and k, because that's really just the coordinates of the center. M, of course, represents the slope. Since the center for this problem is 0, comma 0, that means this k is 0 and h is 0. What about the slope? Look at this asymptote. Rise over run. This is up 3 over 2. So this is just going to be plus or minus 3 over 2. So the equation becomes y equals plus or minus 3 over 2x, again because of the zeros. The plus and minus represents both asymptotes. We have one positive and one negative. So that is it for example 4. Let's go ahead and knock out part B. Again, we know we need a 1 over here, so I need to divide everything by 144. Now, 9 goes into 144 16 times. So this first fraction will become y squared over 16. 16 goes into 144 9 times. So the second fraction will become x squared over 9. And of course we'll have equals 1. So this is standard form, and I will use this for the rest of the problem. Don't forget that right now we know which way the hyperbola opens. Because the first term, the positive term, is the y term, we know that this will be a vertical hyperbola opening up and down. So whatever else we do, we're looking for this shape to the hyperbola. Now, the first denominator, the positive denominator, is always a squared for hyperbola, which means that the a value is 4. We will use this a value to find the vertices. Now, because the 16 is the denominator of the y term, I will do this plus or minus 4 in the y direction. I guess I should formally mention, we know that the center is 0, comma 0. Because we simply have x squared and y squared, not x minus 3 squared or y plus 2 squared or anything like that. So the center is 0, comma 0, so keep that in mind. Now, like I said, the a value is 4. It's with the y term, so I'm going to do plus or minus 4 in the y direction, starting at the center. So if I go up 4 and down 4, these will be my vertices. So 0, comma negative 4, 0, comma positive 4. All right, those are the vertices. Similarly, we can find the co-vertices. The negative denominator, the second denominator, will always be b squared for hyperbolas. So therefore, b is going to be 3. Since the 9 is the denominator of the x term, I will do plus or minus 3 in the x direction. So starting from the center, I will go 3 to the left and 3 to the right. These will be my co-vertices. So negative 3 comma 0 and positive 3 comma 0. The vertices and the co-vertices define a rectangle that will reveal the asymptotes. So go ahead and draw the rectangle that contains the vertices and co-vertices. All right, make it a dotted line like this. Because the asymptotes will pass through the diagonal of the rectangle. Okay, so this is up 4 over 3. All right, so I'm just going to make sure my asymptote passes through the corners of this. Okay, we could draw the branches of the hyperbola right now. We know that these red dots are the vertices. So the branches will extend from these vertices and approach the asymptotes like so. So there's one branch, and here's another branch. Okay, so we've really drawn the hyperbola right now. What else do we need? The foci. We're going to need the c value. So it's time to find the c value. Well, we know that when it comes to hyperbolas, the relationship between a, b, and c is that c squared is equal to a squared plus b squared. So that means c squared is going to equal 16 plus 9, which means that c squared is equal to 25, which means that c is 5. Now, this is the distance from the center to a focus. All right, we know that the foci or foci should be located in the interior of each branch, like somewhere around in here. But now I know that it should be exactly 5 from the center. So that's going to be right here. And 5 from the center this way, we know we will have a focus here. So the coordinates of these points are 0, negative 5, and 0, positive 5. All right, we might as well get the eccentricity out of the way. Eccentricity is always c divided by a, 5 over 4. For hyperbolas, the eccentricity is always bigger than 1. Okay, I think that's everything that we needed except for the asymptotes. We need the equation of the asymptotes. Using point-slope form, we can write the equation of both asymptotes at once. As long as we use the point that is on both asymptotes, which is the center. So you know how the center is always h comma k? So we can write y minus k is equal to plus or minus the slope times x minus h, where h and k is the center. This is the model that we can always use for the equation of the asymptote, or really I should say equations, plural, because the plus or minus, the positive version will be the asymptote that's going uphill from left to right, and the negative version will be downhill. So this is really 2 equations in 1. Since the center is 0, comma 0, that means my k is going to be 0 and my h is going to be 0. So all we need is the slope. Looking at the asymptote that has a positive slope. The slope is just a rise over run. So look at these 2 points, starting from the center and then at the corner of the rectangle. It's easy to see what is the rise and the run. It's up 4 and over 3. So that's why the slope is going to be 4 over 3. Okay, so substituting all that in, I will have y equals plus or minus 4 over 3x. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.